example problem 1.4, page 13 of your General Physics book. I want you to open your General Physics book as well for you to be guided and to be able to follow the process. Alright, during an experiment in a physics laboratory class, a group of 5 students was asked to measure the period of a simple pendulum. Their measurements were as follows. They got 2.3 seconds, 2.4 seconds, 2.2 seconds, 2.5 and 2.1 seconds. So basically there are only 1, 2, 3, 4, 5 trials done. Alright, what we are asked to do here is to determine the mean, variance, standard deviation, and the measured period of the pendulum. Okay, let's start with the mean. Alright, the mean can be solved using the formula x bar equals summation of x over n. We can elaborate this formula by writing or changing summation of x into x sub 1 plus x sub 2 plus x sub 3 plus x sub 4 plus x sub 5 and so on. But we are only until x sub 5 because the trials done here, or the measured values here, is only up to 5 trials over n. Again, the trials taken are 5. 1, 2, 3, 4, 5. Therefore, n is 5. Elaboration. N. So, next thing is the substitution process. Alright, x sub 1 is 2.3 seconds. X sub 2 is 2.4 seconds plus 2.2 seconds plus 2.5 seconds plus 2.1 seconds over n. Again, n is 5. Okay, next is we need to add all the values in the numerator. 2.3 plus 2.4 plus 2.2 plus 2.5 plus 2.1 is 11.5 seconds divided by 5. We have 2.3 seconds. Therefore, the mean in this set of measurements is equal to 2.3 seconds. Okay, next is variance. Formula for variance is sigma squared equals summation of the square of x minus x bar all over n. Again, we can rewrite or we can elaborate this formula by rewriting the numerator. Instead of writing summation of the square of x minus x bar, we will write it this way. X sub 1 minus x bar squared plus x sub 2 minus x bar squared plus x sub 3 minus x bar squared plus x sub Okay, 2.3 seconds minus 2.3 seconds is obviously 0. Square of 0 is still 0. 2.4 minus 2.3 is 0.1 seconds. Let's do this step by step. Plus 2.2 minus 2.3 is negative 0.1 seconds. 2.5 minus 2.3 is 2.2. 0.2 seconds plus 2.1 minus 2.3 negative 0.2 seconds. Copy 5 and then 75. 0.1 squared is equal to 0.01 S becomes S squared plus negative 0.1 seconds is equal to positive 0.01 second squared plus 0.2 seconds is squared is 0.04 seconds squared. And then negative 0.2 seconds becomes squared becomes positive 0.04 seconds squared. Divide by 5. Alright, let's add these values. 0.01 plus another 0.01 plus 0.04 plus 0.04 is 0.1 seconds squared. Divide that by 5. We have 0.02 second squared, which means sigma squared or variance, or the variance from the measurements taken is equal to 0.02 seconds squared. Okay, next is finding out the standard deviation. So we are now down to determining or finding the standard deviation. But what is standard deviation? Standard deviation is the measure of how diverse or how spread out are the set of measurements from their average. It somehow represents the level of uncertainty or error in the set of measurements. It is simply the square root of the variance. It is represented by the Greek letter sigma, of course without the exponent 2. Alright, so let's try. So since it is the square root of variance, meaning whatever we have taken from the variance or whatever the result of the variance is, we simply have to take its root or square root. Okay, so let's copy first the formula for variance. Cancel. This exponent can also be cancelled. Alright, square root of 0.02 is equal to 0.1. So what's left for the unit is second only because the exponent here is cancelled already. So sigma is equal to 0.1 second. And this is already our standard deviation, meaning the level of uncertainty in the set of measurements taken by the 5 students in the given problem is 0.1 second. Okay, last thing we need to find out is the measured period of the pendulum. Okay, the measured period of the pendulum is simply the mean plus minus the level of uncertainty in the set of measurements. Based on our calculation, it is 0.1 seconds. Therefore, the measured period of the pendulum is 2.3 seconds plus minus 0.1 and then the unit second. Alright, that's it. So this sample problem here helps us or teaches us how to determine or calculate variance. Alright, so that is all for today. I hope you understand the topic very well. Thank you for listening, and may God bless us all.